Most people experience this place from above, a calm stretch of water, framed by forest and shoreline, changing color with weather and the season. It looks quiet, predictable, almost still.
But beneath the surface of the Saanich Inlet, nothing is ever truly at rest.
Cold water sinks.
Fresh water floats.
Oxygen disappears.
And returns.
And because of that,
life here plays by a different set of rules.
Today, we're not searching for a specific creature or chasing a dramatic moment.
We're diving into an entire ecosystem.
One shaped by ice, depth, and time.
To understand why this inlet is one of the most unusual and dynamic marine environments on the Pacific coast.
Hey adventurers, and welcome back to BC Adventures. I'm Ryan Swan, and today we're exploring the Saanich Inlet.
Diving into shore sites and boat access walls. Breaking down the oceanography that makes this place so unique. And showcasing some of the incredible marine life that calls this fjord home. Joining me for this dive is Jenna Rose, a marine biologist and instructor at Wilson's Diving. Jenna spent years studying the Saanich Inlet at UVic, and today she's teaching divers in these same waters, bringing science and experience together on every dive. Together, we're going to explore how the inlet functions, from stratification and biological blooms, to the food web they sustain and the ancient organisms that anchor to the reef. Today's adventure is a very different kind of dive.
The Saanich Inlet is a fjord carved by glaciers thousands of years ago. Its steep sides and deep basin restrict how water moves in and out, and that single feature shapes everything that happens here. For most of the year, the inlet is strongly stratified. Fresh water from rainfall and rivers stays near the surface, lighter and warmer while colder, saltier water settles below. These layers resist mixing, creating a stable, sunlit surface zone where phytoplankton can remain suspended and grow. Just outside the inlet, tidal mixing repeatedly pulls nutrients up from deeper water. Each tide delivers those nutrients back down towards the inlet over a shallow underwater ridge known as the sill. The sill acts like a gate. It limits deep water exchange, but nutrients pass through again and again. The result is exceptional biological productivity. Phytoplankton blooms fuel the entire food web here, but as that organic material sinks, bacteria break it down, consuming oxygen, and sometimes creating seasonal, low oxygen or anoxic conditions at depth. Then, once a year, dense, oxygen-rich water spills back into the inlet during deep water renewal events, resetting the system. Loss, renewal, repeat. For divers, this explains everything, from dramatic swings in visibility to the timing of life itself. And when the phytoplankton blooms peak, something unmistakable follows.
You can see the inlet cycle most clearly when the jellyfish arrive. They appear quietly at first, a shape drifting past the edge of the frame, then another and another, until suddenly the water feels full. They arrive quickly, and sometimes in astonishing numbers. Jellyfish don't swim the way fish do. They drift, they pulse, they respond directly to the chemistry in the water itself. When jellyfish appear like this, it isn't random. They're responding to plankton blooms, nutrient pulses, and subtle changes in temperature throughout the water column. In the Saanich Inlet, jellyfish make the invisible visible. They are signals. When jellyfish fill the water, the inlet is telling us something important. It's feeding. And where plankton thrive, the rest of the ecosystem soon follows.
The lion's mane jellyfish is the largest jellyfish in the world. Its bell can grow wider than a person is tall, while its tentacles can trail for tens of meters behind it. In the inlet, they move slowly and deliberately, their long tendrils forming drifting curtains that smaller fish instinctively avoid.
Those tentacles are armed with thousands of stinging cells, powerful enough to subdue prey, yet finely tuned to changes in temperature and plankton density. When lion's mane jellyfish appear in large numbers, it often signals a strong plankton bloom deeper in the water column.
Moon jellyfish are far easier to miss. Their bodies are clear and delicate, ghost-like shapes that pulse gently as they drift through the water. They feed almost exclusively on microscopic plankton, making them excellent indicators of water quality and seasonal change.
When moon jellyfish dominate the inlet, it often means the plankton bloom is widespread, but relatively gentle, evenly distributed rather than explosive.
Then there's the fried egg jellyfish. Bright yellow centers surrounded by translucent bells, they stand out immediately against the green water, drifting like small suns through the inlet. These jellyfish are often associated with warmer conditions and strong surface productivity.
Their presence can signal a shift, not just in temperature, but in the structure of the plankton community itself. When conditions are right, they feed, grow, and reproduce rapidly, filling the upper layers of the water column.
Taken together, these jellyfish tell a larger story. They reveal when nutrients surge, when layers mix, when the inlet breathes in or out. They're not just drifting through the system, they are the system, made visible.
To truly understand the inlet, you have to go deeper. Near Saanich Island and Christmas Point, cloud sponges rise from the darkness like ancient monuments. Glass-bodied, fragile, hundreds of years old, they filter enormous volumes of water, shaping the chemistry of the reef around them. They were long alive before modern dive gear existed, and if we're careful, they'll remain here long after too. And where structures exist, life quickly follows. Squat lobsters cling to the rock faces, glowing red beneath dive lights. Northern kelp crabs move deliberately through the forests of algae, picking at whatever the tide delivers. Red rock crabs patrol the reef, armored and confident, recycling what others leave behind. Nothing here is wasted. Every fallen jellyfish, every discarded shell, broken down, consumed, returned to the system. This is the quiet machinery that keeps the inlet alive. Some of the most remarkable animals in the inlet are the easiest to miss. The big skate spends most of his life on the sea floor, relying on camouflage rather than speed. Its mottled coloring blends almost perfectly with the inlet's sand and silt, making it nearly invisible when resting. Broad wing-like fins allow skates to glide efficiently in low-current environments, conserving energy while headhunting bottom-dwelling prey like clams, worms, and small fish. The inlet's soft sediments and relatively stable conditions make it well suited for this slow, deliberate lifestyle. Even so, encounters are rare. I've only seen two here, one at Moses Point and one at Henderson Point, and both times I nearly swam right past. In the Saanich Inlet, seeing a skate isn't just about luck, it's about slowing down too.
Not long ago, this animal all but vanished. The sunflower sea star, once one of the fastest and most important predators on the reef, were devastated by a wasting disease that swept the Pacific coast. From Alaska to California, populations collapsed. In many areas, they have yet to recover. But here, in parts of the Saanich Inlet, something remarkable is happening. Juvenile sunflower sea stars are appearing again. Tiny arms cling to kelp fronds hidden among the forest canopy. They are small, vulnerable, and easy to miss. This is not a full recovery, but it is a return. And in ecosystems shaped by balance, even small returns matter.
Humans too have left their mark on this inlet. Small wrecks lie near Henderson Point and Mackenzie Bight, their outlines softened by time and growth. Deeper still rests the Deep Cove rail barge, steel now transformed into reef, shelter, and habitat. Even our debris becomes part of the story. The Saanich Inlet isn't just one dive site. It's a living system, shaped by glaciers, storms, and seasons, constantly changing, collapsing, and rebuilding itself. What we see underwater isn't random. It's the result of forces working together over time. Every dive here tells a story, and no matter how many times you return, there's always another layer to uncover. We've only just scratched the surface. We'll see you next time when we take a deep dive on BC Adventures.